Welcome to this deep dive. Today we're really looking at the massive tectonic shifts that are just reshaping the data analytics landscape in 2026.
Yeah, it is a huge year for data. The ground is completely shifting underneath the profession right now.
It really is. And we're pulling from this incredibly comprehensive industry brief today. It covers the biggest data, AI, and architectural trends that are currently dominating the enterprise.
Right, but our mission today isn't just to, list off a bunch of fancy new technologies. We really want to figure out what this means for you.
Exactly. Like if you are an enterprise data analyst listening to this, your day-to-day life, your job description, even the expectations placed on you, they are fundamentally changing.
Oh, without a doubt. And I think the scale of this change is actually best understood through the financials. Global spending on big data and analytics is hitting this staggering $420 billion this year.
Wait, 420 billion. That is just insane.
Right. It's a massive reallocation of corporate wealth. And it's basically driven by a couple of critical breakthroughs. First, large language models, or LLMs, have finally become reliable enough for actual production-level analytics.
Okay, yeah, that's a big one.
And second, edge computing has become so cheap that organizations can now run inference, right close to the actual source of the data.
Let's pause right there because I really want to make sure we're completely grounded before we move forward. When you say run inference right close to the source, mechanically, what does that actually mean for the data flowing through a business?
Yeah, good question. So think about a smart security camera in a retail store. In the old days, that camera had to stream these massive video files all the way back to a central cloud server just to count how many customers walked through the front door.
Which takes a lot of time and just massive bandwidth.
Exactly. It was super inefficient. But inference at the edge means the camera itself now has this really cheap built-in AI chip. So it does the math, the inference, right there on the physical device.
Oh, so it's not sending the actual video back to the cloud at all?
No, it just sends this tiny little packet of text saying, 15 people entered at 9 a.m. It's completely instant, and it costs a fraction of the compute power.
Wow. And I imagine business leaders are seeing this kind of speed, and suddenly they've officially run out of patience for those old, slow insight cycles.
You hit the nail on the head. They want it now.
Okay, let's unpack this, because that loss of patience directly alters what an analyst does all day. The business leader wants faster insight, so obviously the tools have evolved to eliminate the wait time.
Right. The brief actually gives a really great example of this. Imagine a sales manager who wants to know why third quarter numbers dipped.
Yeah, in the past, they would have to, file a JIRA ticket, wait a few days for an analyst to write the SQL query, format a chart, and then email it back.
Exactly. A total bottleneck. But today, generative AI copilots are built directly into the analytics platforms themselves. So that same manager just types a plain English question into a chat box.
And behind the scenes, the AI is essentially translating that English into executable SQL, right? Like scanning the database and running the query itself.
Yeah, it does all of that, and then it generates a narrative explanation right alongside the chart. Absolutely no human analyst required for the retrieval part.
Which fundamentally shifts the analyst's role. I like to think of it this way. For the last decade or so, the data analyst has basically been a short order cook.
Oh, I like that analogy.
Right. Like a ticket comes in, give me a revenue chart, you flip the data burger and you slide it across the counter. You're just endlessly fulfilling these repetitive orders.
So fun.
But with these co-pilots, the analyst has to basically become the head chef. You aren't cooking individual meals anymore. You are designing the menu, setting up the kitchen infrastructure, and ensuring your automated sous chef, the AI, is actually pulling from the right pantry.
What's fascinating here is the sheer velocity of this transition. It is not some gradual phase in. The brief highlights data from Gartner showing what they literally call a cliff jump in adoption.
A cliff jump? Like, how drastic are we talking?
Well, in 2023, less than 30% of enterprises had deployed AI-augmented analytics. By 2026, we are at over 80%.
Oh, wow. Over 80%. That's practically everyone.
Yeah. That means this head chef transition isn't just some future state to prepare for. It is the current immediate expectation.
So the analyst of tomorrow isn't really the person who memorizes the most complex SQL syntax anymore.
No, definitely not. It's the person who understands the business context deeply enough to architect the system and, prompt the AI effectively.
That makes a lot of sense for a human asking an AI a question. But the brief goes much further than that, right? It introduces this concept of agentic AI.
Yeah, this is where it gets really wild. We're moving totally beyond the pull model, where a human has to actively ask for data.
Right, because autonomous agents are now automatically and continuously pulling reports, monitoring metrics, and just collaborating with other software without even being explicitly prompted.
Exactly. The shift from AI as just a tool to AI as an active agent is profound. Like a tool waits to be swung, right?
Yeah.
An agent actively looks for the nail.
That's a great way to put it.
By 2027, the projections show that 50% of all business decisions will be augmented or automated by these agents, and 60% of repetitive data management tasks will be entirely handled by the system.
60%. That is an unbelievable amount of an analyst's day reclaimed. But I feel like this introduces a massive, honestly terrifying new variable.
How so?
Well, if an autonomous agent is continuously monitoring systems and making business decisions on its own, it's entirely dependent on the quality and the speed of its food source,
Yeah,
right?
absolutely.
Like, if you feed an ultra-fast agent old, stale data, you don't just get a delayed PDF report. You trigger an instant catastrophic business error.
Yeah, which is a perfect transition into why the underlying plumbing of enterprise data is being totally ripped out and replaced right now.
Because the shift in how we analyze data with these agents forces a massive shift in what data we analyze and how fast we process it.
Yes, exactly. Real-time analytics is no longer some luxury feature just for tech giants. It is default infrastructure now for finance, e-commerce, healthcare, logistics, you name it.
The brief actually gives a highly memorable reality check on this. Imagine trying to run a high-frequency trading algorithm for Bitcoin based on last week's closing price.
Yeah, you'd go bankrupt in about 2 seconds.
Right. Or imagine a brand trying to run an automated social media campaign by tweeting based on what was trending 30 days ago. It sounds completely absurd.
It does, but honestly, many legacy businesses are essentially doing just that. They're letting their brand new AI agents operate on data that was processed in some batch file last Tuesday.
And when an incredibly fast agent reacts to last Tuesday's reality today, it actively damages the business at the speed of light.
Yep, it's a recipe for disaster.
Here's where it gets really interesting. But wait, let's play devil's advocate for just a second here. Does a standard, I don't know, mid-market clothing retailer actually need the microsecond latency of a Wall Street crypto trader?
That's a fair point.
Because setting up true real-time streaming infrastructure is notoriously expensive and super complicated. So are analysts really building microsecond pipelines for every single metric, or are they just trying to find a sweet spot?
This raises an important question, and it points directly to the concrete day-to-day impact on the analyst's job. No, a standard retailer absolutely does not need microsecond latency for everything.
Okay, so it's not just make everything real time.
Right. Streaming data continuously is incredibly resource-intensive and expensive.
Yeah.
So the analyst is now essentially operating as an architectural economist.
An architectural economist. I like that. So they have to sit down with business leaders and actually perform cost-benefit analyses on data velocity.
Exactly. They are actively deciding the speed limit for different types of information based on its actual financial value to the company.
Give me an example of how that works in practice.
Well, an analyst might decide that, say, inventory levels during a huge Black Friday sale are mission critical. So they build a true real-time streaming pipeline just for that specific domain.
Makes sense. You can't sell what you don't have.
Right. But for daily regional sales totals, they might utilize microbatches. Mechanically, that means the system just gathers data in small chunks and processes them every 15 minutes rather than continuously.
Which is much cheaper, but still fresh enough for a regional manager to use.
Exactly. Or they might just rely on cached metrics that update once a night for a long-term forecasting agent. The point is, the analyst is the one designing the velocity.
That is such a fascinating evolution of the role. You're not just moving the data around anymore. You're literally valuing its freshness.
Yeah, you're tying data speed directly to business ROI.
And speaking of the data itself, we really need to talk about the massive vault of information that these AI agents are suddenly able to read. The brief dives heavily into NLP, or natural language processing.
Yeah, we touched on NLP briefly when discussing those copilots translating plain English into SQL, but its application goes way, way beyond just querying databases.
Right, because NLP is finally cracking the code on unstructured data.
Exactly.
Yeah.
For decades, relational databases kind of forced everything into these neat, tidy rows and columns.
But human interaction is not neat and tidy. It's customer reviews, angry support tickets, sprawling social media threads. It's totally messy. It's unstructured.
And historically, that data just sat there, mostly ignored because it was too hard to analyze at scale.
So how does the analyst actually use that now? I mean, I understand an AI can read a paragraph, but mechanically, how does opinion mining or sentiment analysis turn thousands of angry customer emails into a solid metric an analyst can actually put on a dashboard?
Yeah, it sounds like magic. But at a mechanical level, modern NLP models basically convert words and sentences into high-dimensional vectors.
Okay, vectors. So essentially turning human language into complex coordinates of numbers.
Precisely. And by mapping these numerical coordinates, the algorithm can calculate the proximity of a customer's specific phrasing to known markers of frustration or satisfaction or urgency.
Oh, I see. It literally assigns a mathematical weight to the human sentiment.
Yeah, so suddenly a chaotic inbox of 10,000 support tickets becomes a neat, quantifiable time series graph. You can literally see a 15% spike in customer anxiety following a new product release.
Which means the analyst's available dataset just absolutely exploded. You aren't just tracking the binary fact that a customer returned a pair of shoes anymore.
Nope. You are correlating that return data in real time with the numerical sentiment score of their interaction with the chatbot.
Giving the enterprise an infinitely richer, albeit far more complex, picture of reality. It's incredible.
It is, but it's also a double-edged sword.
Yeah, let's take a step back and actually look at the engine we've just described here, because I think this is where the danger really
The
lies.
governance side of things.
Exactly. We have lightning-fast autonomous AI agents. They are pulling insights from massive, unstructured, real-time data pools. They're reading social media, translating sentiment into numbers, and making automated decisions.
All without human intervention.
Right, so if the sentiment model is biased, or if that microbatch pipeline we talked about fails, the AI doesn't just generate a weird-looking pie chart for some PowerPoint deck anymore.
No, it automatically triggers a bad business decision. It might automatically issue thousands of unnecessary refunds or dynamically lower prices based on a totally hallucinated trend.
So what does this all mean? To me, this entire setup feels incredibly precarious if it isn't managed perfectly.
Oh, it is.
It's like taking a Ferrari engine, these ultra-fast, incredibly powerful AI agents, and dropping it into a chassis with absolutely no steering wheel.
Yeah, that's a good visual.
You have zero governance, you have no way to steer the insights or verify the safety of the decisions. And to make matters worse, you're trying to max out the speedometer of this supercar on a one-lane dirt road.
And that dirt road is the old centralized IT department.
Yes, where every single data request creates a massive bottleneck. The car is basically guaranteed to crash.
And the statistics in the brief back up that impending crash, actually. It highlights what it calls the ROI paradox.
The ROI paradox, what's the data on that?
Well, despite an average annual spend of $250 million on data initiatives, only 37.8% of Fortune 1000 companies actually classify themselves as truly data-driven.
Wait, spending $250 million a year and still failing? That is wild.
It really is. The vast majority of these companies are just failing to govern this new machinery. It is a profound governance failure.
Because in the old reporting paradigm, a broken data pipeline just meant a broken dashboard. It was annoying, for sure, but it was contained.
Right. But now, as AI moves to production, accuracy without traceability is an existential liability. If an algorithm makes a decision, the enterprise absolutely must be able to prove exactly why it made that decision.
They need to know what data it used and who owned that data at the exact time of the query.
Exactly, especially considering the legal environment right now.
Oh, yeah. The brief points out that over 140 countries are actively enforcing complex privacy laws right now. You've got GDPR in Europe, the AI Act, the CCPA out in California.
You definitely cannot just unleash an autonomous agent on your customer data without a rock-solid audit trail. It's a massive legal risk.
If we connect this to the bigger picture, fixing this requires a total teardown of that one-lane dirt road architecture we talked about.
Completely. And the brief points to two major structural fixes that organizations are heavily investing in for 2026: lakehouses and data meshes.
Okay, let's break those down, starting with lakehouses, because I hear that term thrown around a lot. Is it just a marketing buzzword, or is there a real mechanical difference here?
Oh, there is a very real mechanical difference. So historically, organizations had data lakes, And those were great for cheaply dumping massive amounts of raw, messy, unstructured data, like all those raw customer emails we mentioned.
Right, but they were notoriously a nightmare to query, just a swamp of text.
Exactly. Then, on the other hand, you had data warehouses. Those were highly structured, governed, and super fast to query, but they were very rigid and expensive.
So a lakehouse literally merges the two architectures.
Precisely. It applies a structured transactional metadata layer directly on top of the cheap data lake storage.
Oh, wow. So an analyst can use standard reliable SQL to query the messy, unstructured data just as easily as they query the clean transaction logs.
Yeah, and without having to copy the data into two totally different systems, it creates a completely unified technical foundation.
That sounds incredibly efficient.
It is, but the technology alone isn't enough to solve the bottleneck issue. That requires a fundamental organizational shift, which is where the data mesh comes in.
Right, the data mesh. Because that decentralizes data ownership, doesn't it?
Yes.
How does that actually work in practice for a company?
Think of it kind of like a franchise business model.
Yeah.
Instead of one overwhelmed corporate headquarters trying to manage the inventory for 1,000 different local restaurants, you just give ownership to the local managers.
Okay, so in a data mesh, you stop throwing all your enterprise data into one centralized IT team.
Exactly. Instead, the marketing team physically owns and governs the marketing data. The logistics team owns the supply chain data.
So they basically treat their data like a product that they serve to the rest of the company.
Yes, exactly. They become the true domain experts.
Yeah.
They're responsible for the quality, the privacy compliance, and the real-time availability of their specific data sets.
This sounds like it completely rewrites the day-to-day life of our listener, the enterprise data analyst.
Yeah.
If we are decentralizing everything, the analyst doesn't just sit in an IT basement anymore pulling tickets.
Not at all. They are embedded directly into the business units. You become the dedicated analyst for marketing, sitting right next to the chief marketing officer.
Which means you understand their specific strategic needs. And that context is what allows you to determine if a pipeline needs microsecond latency or just a daily microbatch like we talked about earlier.
Exactly. It allows you to design the strict governance rules required for that specific marketing data and to craft the highly specific prompts that your generative AI copilot needs to actually function safely.
Because if you don't understand the specific business domain, you really can't be the head chef. You literally wouldn't know what kind of restaurant you're running.
That's the perfect way to summarize it. The organizations winning in 2026 are the ones treating AI, real-time pipelines, and decentralized data meshes as a single, unified strategy.
And the analyst becomes the essential bridge between the domain's business strategy and the automated agents executing it.
Absolutely.
Man, this has been an incredibly dense, revealing look at the reality of 2026. To briefly recap for everyone listening, we're living in a landscape where autonomous agentic AI is officially ending the old pull model of waiting for reports.
Yeah, the agents are doing the work now.
We have natural language processing unlocking vast reserves of unstructured text, essentially turning messy human emotions into quantifiable metrics.
Right.
And we are seeing real-time data become an absolute necessity,
Right.
which is forcing analysts to balance infrastructure costs against actual business value.
And tying it all together, we see how decentralized data meshes and lakehouse architectures are really the only ways to establish the strict governance required to keep these AI agents from becoming massive legal and financial liabilities.
It is a paradigm shift in every sense of the word, and the brief makes it overwhelmingly clear. 2026 is the year to act. So for you listening right now, you really have to look at your own organization and ask, is your infrastructure genuinely built to act on data, or is it still fundamentally designed just to report on it?
Yeah, it is the difference between navigating the road ahead in real time and trying to drive by just staring at the rearview mirror.
Which leaves us with one final kind of provocative thought to mull over. We've talked about data ownership being decentralized to individual business units via the data mesh.
Right.
And we've talked about AI copilots seamlessly handling routine SQL generation, dashboard building, and standard reporting. So if all of that becomes the baseline standard, will the traditional title of data analyst even exist in 5 years?
Ooh, that's a tough question.
Or will everyone simply become a business strategist, armed with their own personalized, fully governed AI? Something to think about as you navigate the new data landscape. Thanks for joining us on this deep dive.